Hey guys, Mr. B here again, bringing you another video from Calculus to Trig unit. So here is a video on derivatives of inverse trigonometric functions. So one of the things we talked about in class, one of the things we went through was deriving all these. What's the derivative of arc sine, arc cos, arc tan, all those things. But the reality is, guys, I'm never going to ask you to prove one of those on a test. I'm going to give you an example where you have to apply that. So you have to know. You don't want to be on a test trying to derive what these things are. So you have to just know them. That's, it's important, understand where they come from and things like that. But at the end of the day, you just need to know them. So this is an example where you have to find a derivative involving cos inverse. So of course, where do we start? We have to know what the derivative of cos inverse is. Well, so easiest way is to think of it like this. So d over dx of, maybe I'll actually go to a new slide. So arc cos, so that's another way of saying cos to the negative 1. So d over dx of arc cos of u. So u is just like, anything could be in there, x in our case, or x squared in our case actually, is equal to negative 1 over the square root 1 minus u squared times u prime. So that u prime is what's inside our cos. So in our case, it'd be x squared. So we're going to be looking for what will go in there. Well, what will go in there is the derivative of x squared. So let's go back to our function and see if we can apply this. So the very first step is, y prime is equal to negative 1 over square root 1 minus. Now if you look back, just go back for 1 second, that's u right there. So we got u squared. So we have to kind of be careful at this step and recognize that we're going to put x squared right there. So x squared, just like that, and then squared. So that we got to kind of be careful. And then times u prime, well, that's just whatever the derivative of x squared is, so that's 2x. So we end up with negative 2x all over square root 1 minus x to the 4. And, I would be certainly happy with it left like that. So there's your derivative right there. So, if you don't know your derivatives of your inverse trig functions, this is a nearly impossible question. But if you do know it, it's pretty straightforward. So hopefully this helps, guys, and I'll see you guys in class.